starting up with graphs in algebra. So the graphs that we know are straight line,
Hyperbola,
hyperbola, parabola, exponential. For all of them, you have got to be able to sketch them and
find the
equation. And then these next exercises, a combination of that. They give it sketch, but they don't always give you the equation. And then they're asking you for the equation. But so it's a mixed thing. Right. So this question said, the following sketch shows F, there's F, and then also G. G is in the blue, then just put the G there in blue. But they didn't give me any sort of equation there. Usually they do this. They give you the general equation. But the first question was, find for me prove that A, B, and C are -2, 4, and 6. That's the question. Go prove it. So what do? You don't substitute it in and say yes it is. No marks. This would be a 4 or 5 mark question. If they're asking me to go prove that A is, B is, and C is, what are they actually asking me? Find the equation. Excellent. So now finding the equation of a parabola. How many things have you got in your toolbox? Finding the equation of the parabola. How many ways? 2 ways. Namely, turning point and a point. X-intercepts and a point. And each of them have their own formula. Is this the formula?
No.
No? That's just what they're giving me. Eventually it's going to look like that. Because they want it to be in the form ax squared plus bx plus c eventually. But you either start off with the turning point formula or the x-intercept formula. What have I got on the sketch? Now you must start reading all the stuff. They told me, yes, you do have the 2 x-intercepts and you have a? No, you don't have a turning point. You've got the y-intercept, which is another point. So working out the equation would mean I have to go find the form or use the formula. X minus x1, x minus x2. A note to take notice of. That A in the formula ax squared plus bx plus c. That A in the formula A, x minus x1, x minus x2. And the A in the formula for turning point. Is that the same A? Yes. Otherwise they would have called it something else. So if I know that A in this format was 2, then it would have been a 2 over here. And if I take it to turning point, it has to be a 2 then as well. All of those A's are the same A, which shows me the shape and how wide or how narrow it should be. Now, what substitution with the x-intercept, you're going to have +1 and -3. Remember, the formula has a negative in there. It's the girl story. So if there's a +3, this must be a -3. If there's a -1, this must be a +1. What am I short to get the equation? What am I shorting? A. If I short just one variable, how do I find it? Substitution of a point. Which point? The 6th one. What will happen if I choose to go back and say 3 and 0?
You won't get an answer.
There will be no answer. The A will disappear. I've told you that. If the thing that you're looking for disappears, you chose the wrong point. Don't stress too much about it. If it happens, just choose another point. What is the other point? Because actually you've used point 1 and point 3 already. That's why you need the other point, which is point not 6006. So in the place of y, 6, and in the place of x, 0. 0, 0, and 6. I'm solving for A. This is 1. This is -3, and you've got to multiply them. So A times 1 times -3 is -3A. Solve for A. Divide by -3 and you get -2. The fact that it's negative should be good news because it's a frowny face. What negative, I don't know. -1/2, -4/6, or I don't know. Doesn't matter. At least it's negative. Am I finished?
No.
No, the equation should be y equals -2, x plus 1, x minus 3. Do I ever leave it in x-intercept form?
No,
Whether they ask me or not,
you don't.
you have to time it out. But there's another reason why I have to time it out, because they're looking for A and B and C. If there was an A and a B and a C on the sketch, was it that A and B and C? Remember that small letters is something else other than capital letters, which are points, which might have been an x-intercept or a turning point or whatever. Just take note of that. So if I want it in the form ax squared plus bx plus c, I need to time this out. Rules. What do you time out first?
The foil.
First you do the FOIL, then you time out the minus 2. Good maths organization skills. So you've got x squared plus 1x and minus 3x is minus 2x. If you want to first write that, please do. Plus 1x and minus 3x. Plus times a minus is a negative. 3 now timing it out. Negative 2x squared plus 4x and plus 6. Right. So that is the equation of fx. So I can put the fx over here. If you don't know, we're going to deduct a mark from you. No, it's just showing I'm doing f. Did I answer the question?
Yes. Oh no.
Please tell me, yes. Do you see A is negative B? Negative.
Negative 2.
Negative 2 and B is
4.
4 and C is
6.
seeing it there. Feels like too much, but I asked you for ABC, so you highlight on your question paper. Prove that it is. I'll prove that it is, so that you don't forget to write something that's actually silly. Don't forget to write it. Now, second part of the question says, write this equation in the form of the turning point. Write this one that you've just gotten in the turning point format. What technique am I using? To get it into square form.
Oh, complete the square.
Completing the square. But actually you're busy finding the turning point, aren't you?
Yes.
So ma'am is saying, if you want to, why don't you go get the turning point? How will I get the turning point?
By completing the square.
Yes? How else do you get the turning point? There's a formula for turning point. Excellent. Which B and A? The ones I just got. And I will find the x value and I will find the y value by substituting it back. Say for instance, your turning point is, let's make it something that's not true. Let's make it 2 and 9, if I found it here. Then I can go back here and say, but that must be minus 2. And will that be okay? You can do that technique. Finding the turning point, going back, because this is actually turning point formula. Only thing is I still short the A.
Don't you have?
I have the A. What's what I was talking about just now. That A must still be negative 2. So whether it's in the form of the turning point of the x-intercepts, the A is negative 2. Whether it's in ax squared plus bx plus c, the A is negative 2. Whether it's in this format, it's still going to be negative 2. So if you did that, and the answer is not right, please. If you did go find the turning point and go back there, could I say you don't get the marks? No. But they did want you to use completing the square. But I'm telling you now, if you did this, found the turning point and put it back in here, there's nothing wrong with that. So let's revise a little bit again what the completing the square method is. First of all, you take your equation, plus 4x plus 6. Now you need to go and complete the square. Rules for completing the square, that times with a half and squaring thing, right?
Yes.
Okay? But you cannot do that unless the coefficient of x squared is 1.
Oh.
You cannot do it unless the coefficient is 1. So how do I deal with that? Divide the whole thing by negative 2. Why can you not divide the whole thing by negative 2? It's not an equation, it's an expression. This is a formula for a parabola. That negative 2 means something about the form and about how fat it is, etc. And 6 is the y-intercept. You can't divide it by 2 and now it's actually 3. Okay. So you have to take away the 2. It's still an equation, the formula for a parabola. Then If you take out the 2 there, we're also going to take it out there by the x. Now, if you still remember back 2 months ago, then the next piece is, I don't care about that 6, just let it stand there on its own. Get out of my way. I need this to complete a square. So first of all, you must make that coefficient 1 by taking out the 2. And we had some horrible ones that you took out the 2 that there isn't actually a 2 to take out. Now you need something over here that I'm going to write in another color, and that something is, you take the 2 and you times it by a half and you square it. And if you do that, it's 1 squared, which is 1. Are you with me? So I'm needing a plus 1 here to complete the square. To complete the square. But I can't just put stuff in there. Originally, timing it out with the blue, it was the same thing. But now I've just added plus 1 in here. Have I added plus 1 to the sum?
No.
You have added?
Negative.
Minus 2.
Oh.
Because the plus 1 is inside of the bracket. And it's been timed with negative 2. So what has been added to the sum? Negative 2. So what must I say here? So that just feels totally wrong if you just look at it and say, man, you've got to add 1 and then add another 2. I didn't add 1. I added 1 times negative 2, which is negative 2. So I've got to say plus 2 as well. Completing this square is never on any basis a level 1 sum. Never. So now let's carry on. Y is going to be equal to that. Negative 2 stays there. Then we complete the square. What's the routine? First you get the square root of x squared, which is x. Then the sign, which is plus. Then the square root of 1, which is 1. Then we go to this side, and the answer there is plus 8. What have I just achieved? That the turning point, and it's called T, is?
1 and 8.
I'm sure I made a mistake. I did make a mistake. Okay, good thing to see. Why do I know it's a mistake? It can't be on the negative side. Do you see the logic here? If you made a mistake, you're going to find out you made a mistake. I saw what the mistake is already. Check it out, check it out. But why do I know? It's on the right hand. It should be plus. But this one should change signs. But the problem was, who saw it? There's the plus. That should have been a, because a minus times a minus gives me back a, that was the mistake.
Oh.
Nothing else was wrong, because that's still going to be plus 2, no other problem. So then, let's go through it again. Square root, the sign should have been a minus and square root again. Are you here with me?
Yes.
Do you see that if you make a mistake and you look at the logics behind it, it should somehow come to you and say, something's not like that. Let me check where I made a mistake. So that the turning point then is positive 1 and 8. Positive 1 and 8. So there's my turning point 1 and 8. Couldn't I have judged the x value of the turning point though? Think about it. If I'm at the turning point, it should go to the right hand side for the x-axis of 3 and to the left hand side to minus 1. My scale is not so hot here, but okay. So if the turning point comes down here at 1, so from 1 to 3 is 2 units, and from 1 to negative 1 is also 2 units. So couldn't I have figured out that x is 1 by using symmetry? Do you see what I just did? Yes. So halfway between negative 1 and 3 is exactly at 1. Halfway between negative 1 and 3, there's 4 units between. So it's 2 units in between. 2 units to the right or 2 units to the left gives me 1. Are you seeing this? So you could have figured out the 1 there. And then you could have figured out the y anyway. So instead of using the turning point formula, could I have figured out the x value using symmetry? Because a parabola is symmetrical. Please don't think that there's only one way of doing a sum. Ever. Ever. There might be a best way, but there's never just one way. Right, that was the question, first of all, number 2, to write it in that form, and then they want the equation of g, which is the hyperbola. So if I need the hyperbolas equation, do I now have enough information? Okay, I'm going to erase this and we can carry on with that on the next board. So, therefore I know that the parabola in whichever format, in the ABC format or in the turning point format, and I even have the x-intercept format if you needed it for something. I'm now trying to find the equation of G, the hyperbola. Did they give me the general equation? They usually do, but they didn't here. What is the general equation for a hyperbola? But now I'm careful about that A. Pam just said all the A's are the same. No, that's not what I said. All the A's by ax squared plus bx plus c, the A in the parabola, turning point, x-intercept format, or a squared plus ax squared plus bx plus c, in that format, those A's will always be the same A. This is not the same A. So if you needed to go and write it as a K, sometimes we do that in grade 10, or anything else, it doesn't matter. It's just that that A is not the same A as that one. Are you with me here?
Yes, ma'am.
Alright, so if you use it, just be aware of that. You can't make it the same. What is P and Q's purpose here? They are the shifts, the asymptotes, which has been given to me. And in words, the question said that the asymptotes go through 3 and goes through 6. And there was something else also that they said, that the turning point is also on the hyperbola, and I'm going to need that now. For the hyperbola, I now know that I've got to use the 3 because it goes there through the x-intercept. It's also the x-intercept for the parabola, and it's the asymptote. So that 3 is going to help me how? This will be?
-3.
And the Q?
+6.
Plus, minus? Plus, it's a boy, guys. Right, y equals. What is the, they didn't ask it here, what is the equation of the horizontal asymptote? Y is equal to 6. So it could have been a question. What is the vertical asymptote's equation? X equals to 3. And all the hundreds of other questions that could be asked, all right? But now there I am, and I'm still searching for
X.
A. So I need a point. Do I have another point on the hyperbola?
Yes.
Which one?
Coordinate.
Only T. Which you had to find from the previous question when they asked you to write it in turning point format. You see how they combine it and intertwine them. So you're going to substitute your y with an 8, your x with 1, and solve for A in whichever way. But guys, order of operations, you can't do whatever you like. So that 6 is going to become a -6, together with 8 gives me 2. A over -2 because I'm adding them, and then I'm multiplying and it gets to -4. Don't do silly stuff like times with a -2, but it becomes a plus because it goes over the equal signs. It's terrible if you do that still in grade 11. The fact that it's negative should be good news. Why? Because it's, yes, I see you. Quadrant 2 and 4. If it was positive, it should have been quadrant.
First and third.
Okay, so on the asymptotes, quadrant 1, 3, 2, 4. So if it's 2, 4, this should have been a negative, so I feel kind of like alright. So the equation, I'm still not done because they asked me for the equation. The equation then of G should be -4 over x minus 3 plus 6, and now I'm actually done. So when the question says find the equation, did I find it? Oops, I can't stop there. I need to write down the equation. Right, next piece of the question says, find me the axis of symmetry for the hyperbola. But it specifically says, find the axis of symmetry that has a negative gradient. First of all, you know that the hyperbola is loaded. It's got 2 asymptotes and it's got 2 axes of symmetry. Okay, asymptotes no problem, you know where they are and how the equations look like. But what is the axis of symmetry for any hyperbola? First of all, before they start shifting around, it was y equal to x, right? And then plus c, you're quite right, because it's going to move up and down and left and right. This one then should be y equal to negative x, and there is going to be a plus c. At the moment, my c is 0, before there's any shift. But this is the facts that you must know. So I'm saying every 3 minutes I say, this is what you must know. This is your knowledge. This is what you must study. It's heaps and heaps and heaps. So for the axis of symmetry, you've got two. You've got the one that says y equals plus x and one equals minus x. So if you say y equals x plus c, and you didn't read what they said there, y equals negative x plus c, and you do both of them, you're doing double work and you get no marks. Because the question asked you for the one that has a negative gradient. So you shouldn't be doing this one. Now what's the rule when I mark? If you've got 2 attempts,
You do the
I
first
mark
one.
the first one, which is the wrong one. So you got no marks here, unfortunately. Okay. So you have to know that it was the one with the negative gradient. And then what's the rule? You've already got that, so I'm going to give you that mark. But how do I find C? Substitute what? The only thing you can ever substitute that's on those two is where the asymptotes intersect. Because the line goes through there. The line doesn't cut through these. This line does, but it has to go through, what's that point?
Negative 3 and 6.
3 and 6. Not negative 3. What it is, actually is 3 and 6. So 3 and 6 in there. 6 in the place of y. 3 in the place of x. Which means c is equal to 9. Am I finished? Please write the equation down, which is y equals negative x plus 9. Let's think about it. Negative, yes. So if it's going like this, I don't know if it's going through there. It's probably not, so are you with me?
Yes, ma'am.
Then what does the 9 mean? That's that straight lines. Y-intercept. Does it make kind of like sense?
Yes, ma'am.
Because there's the turning point, and that should be a little bit more. I'm not exactly sure, but at least the 9 kind of like makes sense. Axis of symmetry, don't confuse that with your asymptotes. Right, we're still not finished. Right, the very last part of the question, and you'll find them, guys, you need the exam aid. You need to live in that exam aid. You need to see how they get asked. Because now we're only really truly getting to how they get it asked, and now we're finished. Okay. The last part of the question, not all of them, some of them will have something like this in. And real roots, non-real roots, let you think about what?
The discriminant.
Okay, but I'm not going to use it here. So I want you to think about it, but then see what's the practicality of this. Because they're asking me for which values of k will f. F was the parabola. So the parabola equal to k. What's happening?
K method.
Not k method. Equal to k. What is k? It's a value, right? We don't know what it is, but it's a value. So if it was, for instance, plus 1, what would it mean? What is happening to the graph? It's shifting up and down. That's a boy. Right? So you're taking your whole equation, whatever it was, and then saying minus with k equal to 0. So I'm doing a shift. To do what? Listen to the question. For which values of k? So this is the last, and it's worth 2 marks. And here comes a long explanation so that you'll understand what's going on, hopefully, and understand that it's not easy. So if I want this thing in English, I'm seeing I have got to move this thing up and down, because that's what that minus k means. To do what? So that f will not have real roots, or will have non-real roots. At the moment, f has 2 real rational. I don't know that, because negative 1 and 3 are rational. Okay? At the moment, it's got 2 roots, so it has got roots. To have non-real roots, what must happen to this thing? Move up. How far down? Down, down, down. So that the turning point will be over here. If I move it, how much?
8.
Who knows 8? You're fantastic. Yes, because that was the turning point. I need to move it down with 8 units. But if I move it exactly 8, then it is on 1. Is that a non-real root? So you're going to move it more, not 9. What about 8.5, 8.25, 8.1? So more than 8. Okay, so tricky, tricky, tricky. So at least if you got 8, well, you should be getting a mark here. But now what must the k value be? Now remember, I'm moving it down with k. So if I'm moving it downwards, should it be moving down by 8, like I said there? If I move it down with exactly 8, I'm going to have 1 real root. Equal roots, right? Equal roots if I move it down exactly 8. But the question was, what must k be? Must k be 8?
No.
8,5, 8,4, 8,3, 8,1, 8,0, 0, 0, 0, 0, 0, 0.
X is the
Anything?
yes.
Less? Here comes the question. Less or greater?
Less.
Remember, there must be a minus 8. Okay, let's take your example. Or minus 9. Or minus 10. And don't forget all the stuff in between. So it must be, that k value must be, so it must either be 8. No, not 8. More than 8. Or if it's 9 or if it's 10, that value should be more. If you fill it in there, more than 8, it will be minus 8, minus 9, minus 10. And that's your answer. Bigger than. No. There is a minus because they put it there with a plus. It's over here, it's a negative. Now, if they had asked the question like this, what would you have answered? So that k should be negative 8 and more than negative 8, so less than. But you see the question. Right. In that same note, here's the next one. Because that's it. All I want to see is this. Not all the reasoning, but I think you need to reason it out for yourself. If they ask me that it must only have positive real roots, how much must it move down?
Down.
Only positive and real roots. Man's having fun here. So it has to move down. Moving upper and upper is going to mean it goes like this. Going like, there's my shape. You see it going wider. If it comes down at some stage, it's going to only go to the left and the right. And it's going to be here at 0. Where? It must be somewhere over here. Moving somewhat down. So that it could go there, wherever, I'm not sure, it's getting narrower as it goes down. The parabola is not going narrower, but when it comes down, those two values are coming closer together. Right? Coming closer together. But where should that happen? If this has to be 0, and that's whatever's the symmetry on that side, how much?
2.
4.
Okay, don't guess.
2.
How much must it move down to get this down here?
6.
4.
If it moves down 6, where are you? So somebody's saying 6. Then we add?
6. Which page?
Do you agree?
Yes.
If it moves down by 6, then that will be 2. If it's there at 2, I'm not saying move it down by 2, I'm saying move down by 6. And the k is the move. The k has got something to do with the 6. Then, what will happen to your 2x intercepts? Now guys, you don't have time 10 minutes like this in every sum. You have to practice these at home. But now I need you to realize we've got to move it down with 6 units and understand why it was 6. Because then I'll have 1 unit to the left going there to the 0. And 1 unit to the right going there to, that'll be 2. Because it's symmetrical.
Oh.
But how much was the move? That's the basis of it. We don't want to sketch another thing. It was a move of 6. But now what must I write? Because it has to be positive real roots. So it can't go up to infinity. To have positive roots, I at least have to go down with 6. But I can't go down more than 7. More than, because I have to have real roots. So I can't go more than 8. If I go more than 8, remember, 8 was the one that said non-real roots. So you've got to stop there. So basically what this is all about is in between. A move of what? 6 and 8. And that's the answer. And that's the answer, but let's just check it out. So 8 can't be included either, can it? Yes. Because if it's a move of exactly 8, does it have a real root? What do I want? Positive real roots. They never said 2 positive real roots. If they said 2, then I have to exclude the 8. Because that's only going to give me 1. I think you need to go 2 on this. That there's a movement of at least 6 to get it there, that it can be on the positive sides. But then you can't move it more than 8, because if you move it by 8, then it's on the axis, so it's still a positive root. When will it have positive roots? So it'll still have now equal roots, but still a positive root. But not 6. Because if I move by 6, wait. Still getting there, sorry. 6 is also included, but if I move it by 6, I'm going to have 2 real roots. Remember our discussion in trig, whether 0 is positive or not. Now we're still in that same thing. So we're going to include it for that same reasoning that we did in trigonometry. I know we feel that 0 is actually neutral. Not positive, not negative. Guys, that's it. That's the end of the graph story. Okay.